All right, second example. This one's different just because process-wise the same, but we're going to focus on factoring here. So first denominator, factored. Second denominator, what multiplies to get -8 and adds to get a +2? That's p plus 2, p minus 2. And then the last denominator is p plus 4. So those are your three denominators. When we identify LCD, we need to make sure we're taking the highest power of each one. So we need a p minus 2, and we need a p plus 4, in no particular order. So we take each fraction, I would highly suggest leaving it as the factored version of the denominator because it's a lot easier to tell what has to be simplified or what can be simplified. So again, that means I wouldn't leave it as p squared plus 2p minus 8. And then just like we did for the first one, we are multiplying by the LCD. It just needs to be somehow written next to each of your fractions. P plus 4, p minus 2, p plus 4. And then you go and you see what cancels. Again, no denominator should be left over. So the first fraction, the p minus 2 goes away. So we have p plus 4. Second one, they both go away. So you get 2p plus 1. Third fraction, the p plus 4s go away. So you have 2 and p minus 2. So we know we're on the right track because nothing was left over. Now it's a matter of distributing and combining like terms. So we have p plus 4 equals 2p plus 1. Plus 2p minus 4. Keep going with combining like terms, so you get 4p minus 3. And when you move stuff around, we bring the 3 over, we get 7. We get the p over, we get 3. We end up with 7/3. And then what you will find is when you sub that back in, it does in fact